Dear friends, greetings from Copenhagen. My name is Balaji. I am a postdoctoral research fellow in DTU and a research consultant in DBI. I would like to share with you our research, which is titled Taxonomy for Cross-Domain Fire Hazards in Building Designs. And this work has been done in collaboration with a couple of my colleagues named Hannah and Anya. This is the outline of my today's talk. I would like to first take you through, certain perspectives and paradigms about building trends that are happening in the urban built environment, and then take you through what is taxonomy and why do we need a taxonomy, and how did we go about systematically developing one in this particular study. And for this matter, we have taken a case study based approach of a smart home and have developed 10 different hazardous scenarios that which could compromise potential fire safety in future buildings. And then we have analyzed these 10 different scenarios to come up with a taxonomy for cross-domain fire hazards. And finally, I would leave you with certain concluding remarks. Buildings around us, largely in the urban environment, is witnessing a paradigm shift in the design approach, driven by the urge to, cut carbon emissions from the building stocks as a whole, right? And researchers in the United States has proposed that in the next 100 years, there would be new forms of building designs that would emerge in this regard, and both in the commercial and the residential sector, as shown in the picture here. What this means is that building designs are going to turn into new complex systems, predominantly by having a close interaction between systems that are surrounded by the buildings, utilities, environment, urban environment, systems within the building, and occupants and the community as a whole. And there is an interesting, paradigm and use cases that have been developed in a roadmap conducted by NIST in the United States that shows how making use of data, IoT, and artificial intelligence, that fire service community can be better prepared to fight fire in the future urban buildings. Furthermore, an interesting piece of opinion proposed by researchers from NFPA also suggests that in future buildings we will be able to talk to fire protection systems such as alarms, smoke detectors, like the way that we speak to Alexa to ask about the weather updates today. And across all these different paradigms and scenarios, we can one thing that is central is integrated design of buildings. While there are promises of integrated design, there has been equally growing concern in the fire safety and security community as a whole because of this integrated design approach in buildings, and this has been due to several incidences that the community as a whole has witnessed in recent years, starting with, let's say, a Grenfell Tower fire in UK in 2017, which is due to the use of insulation material in the facade of the building. Number two is a battery storage fire in APS in Arizona in the US last year, and then a fault in the fire protection or suppression system in the data centers that has led to service block data center going out of service in Sweden and Romania in recent years. And another classic example is a cyber attack in a hotel ending up locking the guests for a few days within the hotel. Very recently, there has been a new invention in the cyber world, which is called lamp phone, which allows malicious outsider to eavesdrop on conversations of occupants within the building without having access to the data infrastructure of the building. And across all these different scenarios, what's common is, and what comes out is, novel cross-domain fire hazards can be expected more and more in future buildings. And as I mentioned before, thus buildings can be viewed as a complex system of systems, such as the one shown in the picture here, whereas which shows that there could be a lot of interactions between different systems, leading to new forms of information flows between them, and that could compromise fire protection. And in this case, these different systems and their interactions can come from basically different domains, as shown in the picture here, which is cyber, physical, and the social domain. By cyber, we refer to the means by which the information is being stored and processed in a cloud server, for instance. And by social, we refer to the means by which various stakeholders, including the occupants, can interact with the different systems, for example, for improved comfort, right? And in the case of physical domain, we refer to the ways in which the systems within the building can respond to various stimulus coming from different channels. And our work is primarily of developing a taxonomy is primarily inspired by two prior works, namely from Yapolsky and Hartfield, which has developed a taxonomy for cross-domain hazards analysis in smart home setting. However, the difference between these prior studies to that of us is we focus mainly on integrated fire safety and security. And we have also seen that NFP has acknowledged that cybersecurity is not well researched and in the fire protection system, and therefore the fire protections community needs to further more develop understanding about holistically the vulnerabilities offered by cybersecurity for fire protection system. And we believe that our research can provide a lot more detailed insights to a fire safety community and security community as a whole. And this brings us to taxonomy. And by taxonomy, we mean the science and practice of classifying things and concepts, including the principles that underlie such a classification. And we believe that taxonomy can be a very good starting point to study such novel cross-domain fire hazards in new buildings. And we have taken a conscious effort to develop taxonomy based on four fundamental questions as outlined here. Number one is, by what means can an adversary compromise fire protection in buildings using smart installations? And number two, how is fire safety thus compromised? And what are the consequences of compromise? Finally, how does occupants react when they know that there is a compromise of fire protection systems in the building? And for this specific study, we have taken a case study based approach of a smart home, which shows there could be a potential of a lot of different installations and appliances that are integrated to provide improved advanced home automations services and solutions in a home. And this has been motivated based on our visit to a real estate that is being developed outside Greater Copenhagen region in Denmark, as shown in this picture here. Now let's get into the details, which is the nuts and bolts of 10 different scenarios that has been developed by us in order to analyze cross domains and come up with a taxonomy. Firstly, the scenario one is about integrating wireless IoT-based smoke detector with wireless fire alarms. And this particular setup can be jammed using RF jammers, and an adversary, a malicious adversary, can trick open this ceiling windows and doors and get an access to the inside the house and can compromise the fire safety measures that are in place. Scenario two is quite similar. In a similar means, RF communication between the smoke detector and the fire alarms can be compromised by maliciously in several homes in the neighborhood, thereby redirecting all the fire services to this neighborhood and plot a terror elsewhere in the city. Scenario 3 is slightly different. It shows that how integrating wireless door access system with smoke canyons can prevent burglary by fogging the vision of a burglar when he is indoor and locking him up. What it also shows is an adverse effect of this kind of an integration is when there is a real fire and the wireless door access system runs out of a battery. It can prevent the inmates from exiting out and thereby affecting the evacuation of the occupants when it is maliciously triggered. Scenario 4 is a case of how simply stealing, let's say, a smartphone of a resident or even an electric car can provide a means to get an access inside the home and compromise fire safety measures, right? And in this case, the smart home has been automated using the garage door opening automation system, which predominantly works through location-based services provided by the smartphone as a feature, or in this case, as a smart electric car. And scenario 5 is a situation where integrating rooftop with electric energy storage system can be hacked and compromised, thereby letting it to charge beyond the thresholds or discharge beyond the threshold, and leading to overheating and sparking of the batteries and furthermore ignition. And in this case, this integration, if it has been integrated with door lock, it can furthermore affect the evacuation of the occupant in the home during the event of fire. Scenario 6 shows a setup of different home automation solutions. In this case, doors, etc., automated by by having the gateway integrating across all these setups. The ecosystem of these different smart installations can provide a entry point for the malware to enter into the home automation solution, infecting the gateway, turning off the communication, blindfolding it for the residents. Scenario 7 is, however, slightly different. It shows that how wireless smoke detectors can be compromised by malware infestation by a malicious outsider, thereby denying the service in the event of a fire by transmitting more often than it is often required. Scenario 8 is similar to scenario 5 by hacking into the gateway to compromise the energy storage system and leading into sparking and ignition of the batteries. Scenario 9, sorry, is a case of how integrating a gateway with different appliances, in this case, electric stove or a oven, can be, if it is compromised, can be reprogrammed and hacked in order to overheat and cause sparking and ignition of appliance. Scenario 10 is quite similar to scenario 9 in that sense. Integrating gateway with different appliances, in this case smart lighting solution, can compromise the denial of lighting, in this case of vacation mode that is offered by the lighting solution, thereby it can allow a burglar to enter the house. Well, using all these different scenarios that we have shown, I have shown you, we have come up, by analyzing all the scenarios, we have come up with a table that shows what are the different means of attacks that are possible in smart homes, given all these home automation systems, and what are the hazards and what are the consequences, right? And we have classified all these different into 3 main cross domains, namely cyber physical, socio physical, and socio cyber. I will not go into the details of this table. However, in the interest of time, however, I would encourage interested participants to read it from our article. And this brings us to the conclusion. Number 1, the buildings in future urban environment will therefore witness largely a system of systems configuration by design, which makes it challenging for standardization due to the complex integration and interaction or interconnection between different systems and services within the building. And number 2, taxonomy. We have developed a taxonomy in this study, which identified 7 means of attacks across 3 cross domains, having a potential to introduce 4 different types of fire safety hazards in future buildings. Number 3, not only the standards within the fire protection systems that has to be revised, but also the standards governing the entire IoT ecosystem for building designs have to be regularly updated. And what this brings us to is that guidelines and the standards concerning the IoT systems integration in the building designs have to be continuously updated, keeping in pace with IoT products and services that are emerging in the market. Finally, our future works aim to therefore develop rolling guidelines for fire safety inspectors, which will allow them to assess the risk of integrated fire safety and security in the buildings caused by integrating new IoT products and services in the building designs. With that, I would like to conclude my presentation. I would like to thank you for your for the opportunity, and thank you for all your attention. Right, and if you have any further questions, please feel free to drop by my website and drop an email to me. Right, I will be happy to be able to answer them. Thank you once again.